All right, this is lesson 12.5b. In the previous lesson, 12.5a or 12-5a, I go back and forth with that. We talk about dilations and translating an object using matrices. Today, we're going to be rotating and reflecting. So you were probably wondering, when are we going to rotate these things? We're going to do it right now. So it says here, if we read what this says here, is a rotation turns a figure about a fixed point, the center of rotation. You can multiply a figure's vertex matrix by rotation matrix to find the vertices of the rotation image. In this book, rotations are always going to be counterclockwise around the origin. So when you use matrices and things like that, you are not limited to rotating about the origin necessarily, but we're just kind of doing some simple stuff here. And so we are not going to be doing anything more than rotating, say, a triangle or something like that around the origin. So let's get started. This is just a little table, and you wouldn't have to memorize this, but these are the matrices that you use to rotate a set of points about either 90, 180, 220, or sorry, 270 or 360 degrees around. If you multiply by 360, if you rotate something 360 degrees, you get right back to where you were. Notice that 360 degrees, that's the identity matrix. It doesn't do anything. You multiply by the identity matrix, you are right back to the same set of points you had to begin with. So why would you rotate something 360 degrees? I don't know. If you wanted to see it animated, maybe you would want to see that happen. So rotate the triangle ABC by the indicated amount. And what are the vertices of the images? Graph the pre-image and the image in the same coordinate plane. I think it's kind of interesting. Let's just graph the pre-image first. So 1, 1, that's A, 5, 2. Oh, this is really, I gotta make this bigger. All right, let's try this again. That was just so small. 1, 1, you can do this as well. 5, 2, negative 2, 3. So this was A, B, C, pre-image. We don't have those little primes on them. And if you think about rotating this 90 degrees is going to be counterclockwise like that. That's what positive rotation is in math. Not clockwise, which is always kind of like, interesting that's how they did it, but that's how it is. And what we're going to do if we're using matrices, right, is we are going to take the rotation matrix, which is up there above, which is 0, negative 1, 1, 0, and we're going to multiply it by A, B, C, where the first row is the x coordinate, so 1, 5, and negative 2, and 1, 2, 3 is the y variables. And this is a 2 by 2 times a 2 by 3 is the same, so I can do it. And this is why you have to do it in this order. You can't put the triangle coordinates first in the matrix times the rotation matrix, because then you would not have, it wouldn't set itself up like this. You'd have a 2 and a 3 here, or a 3 and a 2, and that wouldn't work. So your answer is going to be a 2 by 3. And maybe as we've been doing these, you can do these without writing all the little steps in the way. So when we do this, we've done this several times with multiplying. This one we're going to be going this way. These we're going to be going down. So this first element here is 0 times 1 plus, which is nothing, right? Plus negative 1 times 1, that's negative 1. All right. When we do the next one, for this little spot right here, still the first row, so we're going to be using 0, but it's the second column, so 0 times 5, that's nothing, plus negative 1 times 2, that's negative 2. And we'll do the next one, this spot right here, first row, 0 times negative 2, that's nothing, negative 1 times 3 is negative 3. Just double checking that's right. Yes, it is. Okay. Moving on, let's do purple. So this guy right here, now we're in the second row, so it's going to be 1, and the first column times 1. 1 times 1 is 1, plus 0 times 1 is nothing, so that's a 1. This guy right here is 1 times 5, which is 5, plus 0 times 2, which is nothing. So that is going to be a 5. Lastly, what color have we not used? Maybe orange. This one, second row, last column. 1 times -2 is -2 plus 0 times 3, so that's -2. And now I'm going to plot this guy, and I'll use orange. So my points then are, I mean, this point right here, right, is -1, 1, and so on and so forth. So -1, 1, that's A prime, and then -2, 5 is B prime, and -3, -2 is C prime. I didn't write the letters in there right away because sometimes in your triangle or whatever shape it is ends up kind of, if you write the letters too soon, you might write over you have a line going right through the letter. Some looks a little sloppy, but this already looks sloppy, so it's fine. So this is my rotated part. So did I do all these things? What are the vertices of the image? Well, I suppose when you do this in your Pearson, you might actually have to write them as ordered pairs like this. We graph the pre-image and the image on the same coordinate plane, all right? I think the next one, I am going to let you give it a try. So I'm going to pause it. You go ahead, do all those steps. This one's going 180 degrees, so you're going to use that matrix and then see if we get the same thing. So really do pause it and do that one yourself so you make sure you've got that one down. All right, so if you really did this problem, right, then you would have something like this after you have rotated it. And if you notice, if you compare the two matrices here, I mean, really what happens when you rotate 180 degrees is that all of the x and y values just switch signs. So if it was -1, it's 1. That's just how it works, and you end up, if you think about it, if you ever use patty paper, and if we're in class, maybe we would use patty paper to do this, or if there wasn't a pandemic or something like that. You can basically take a piece of tracing paper, put it over your graph, and you can trace this. Let's say you would trace this triangle right here, right? And then on your patty paper, which is like tracing paper, it's actually used for hamburger patties. It's what divides hamburger patties and butcher shops, and we also use it in math classes. So you would draw that on top on your patty paper, on top of the one that was already on the paper, and then you would stick your finger or a pencil or something right on the origin, and you'd rotate the tracing paper 180 degrees. Usually you have a little, how do you know it's exactly 180 degrees? You make a little cross sign on your patty paper, so as you rotate, you kind of know, I went 90, 180, how far you went. And then you take that and you kind of, you can see in the tracing paper where it traced to, and then you can kind of lift it up and put that stuff on there, but still with your finger on the patty paper there, so you can kind of lift it and draw some things and put it back down, and you kind of figure it out that way. So that is rotations. Now, if we go over here to reflections, so it says here, if we read it, oops, let me just go a little bit further down so we can see reflections. All right, so a reflection maps a point or a figure in the coordinate plane to its mirror image, using a specific line as a line of reflection. In this book, lines of reflection are going to be, okay, so we are only going to use certain ones. You get more advanced math classes, you can reflect over like any kind of line, x equals 3. You might do that in pre-calculus. I know in calculus sometimes they reflect over lines that are not just the axis, but they don't use matrices to do it necessarily. So this is, we're going to be reflecting over the y equals 0 line, which is the x-axis, which is like this axis right here, right? X-axis. X equals 0, which is a y-axis. We'll flip over that. And y equals x, which is this line. It's a line, the slope of 1 that goes to the origin. And y equals -x, which is this line right here. It's got a negative slope of 1, and it goes to the origin. Remember, these are like y equals mx plus b, where b is 0 and m is either 1 or -1, depending on which one of those you were looking at. Let's reflect. Okay, so now we have a quadrilateral, and that's fun. A, B, C, and D. Let's graph the pre-image. So 2, 1, and you can do this too. 8, 6, 8, 1, 8, 4, 5, 5. What a fun guy, huh? You're really cool. All right, A, ooh, that line didn't go very good. A, B, C, D, and you can do the same. And it says we are going to be, the first one, rotating about the y-axis. So again, you are going to put your matrix here for the reflection, and for the y-axis, if you look at the little table above, that's -1, 0, 0, 1 times this quadrilateral, which is A, B, C, D. It's going to be 2, 1, 8, 1, 8, 4, and 5, 5. And what is this going to equal? I'm going to have to put this one down here because I just don't really have enough space. This is going to be A prime, B prime, C prime, D prime when I get it done. All right, so let's get multiplying here. We're reflecting it across the y-axis. Now, when you think about the y-axis, this is the y-axis right here. So this object, it would be like you taking a piece of tracing paper, tracing this on there, right? And then picking up your tracing paper and flipping it over the y-axis. So your shape should be like over here, right? And you actually could probably do a problem like this without using matrices. You have enough knowledge, and if you have kind of spatial skills, which you do, you could do it. But this is a chapter on matrices, and you have to kind of imagine that. What if you were trying to, let's say it was computer programming, you were doing some graphic things with, say, an object that has hundreds of points, right? This is kind of how computer systems and things, it's a way for them to manage many, many points. We just have 4 points, right? So it's not quite as complicated, but all right, so let's go ahead here. So we're going to do, for this spot right here, -1 times 2, that's -2 plus 0 times 1. So that's going to be -2. We'll do this one here. This is going to be -1 times 8 plus 0 times 1. So that's -8. All right, next one we'll do green. So -1 times 8 times 0 times 4. That's also going to be -8. And the last one here, it's going to be -1 times 5, which is -5. 0 plus 0 plus times 5, which is -5. So actually, what ended up happening with all those points on top is they just changed sign from positive to negative there, right? Let's do the bottom row. This is the y-coordinates. So this one here, it's going to be 0 times 2, which is nothing. 1 times 1, that's 1. This one here, it's 0 times 8, which is nothing. 1 times 1, 1. In fact, what is my pattern I'm seeing? I'm seeing that nothing is changing because nothing's happening with the x-coordinate. 0 times 8, which is the x-coordinate. That's always 0 times the x-coordinate. Nothing is affected there. Plus 1 times 4, this is 4, which you already had. You're taking what was the existing y-coordinate, and you're just multiplying it by 1 so that nothing is happening to that coordinate. All right, lastly, 0 times 5 plus 1 times 5, that's 5. All right, so let's graph this guy, see if I can get that color back that I had when I started. Maybe it's about there. All right, so -2, 1, -8, 1, -8, 4, -5, 5. And again, you may say, and I think it's fair for you to say, what the heck, why are we spending all this time doing this when I could have just graphed that really quickly? Again, this is fairly introductory, but this is kind of how you could manage many, many points. All right. I'm going to pause. I'm going to let you do reflecting over the y equals negative x line. Now, reflecting over a line, negative x line, before I start here is like, let me move this up a little bit so my face isn't in the way. That's this line here. So when you reflect over that line, and that's, I'm getting a little, yeah, okay. You reflect over that line, that's a little different and harder for your brain to spatially get it in the right spot. I mean, whereas when reflected across the y-axis here, like that's kind of easy to see, right? But when you reflect over a diagonal, I don't know. For me anyway, it's harder for me to visualize like what that would actually look like. It takes a little bit of thinking. So matrices are kind of handy here. So go ahead and do this one. Pause it, and I will, when you come back, we'll all be done. All right, so when you get this reflected, if you kind of notice what happened to the points, if you look up here at the matrices here, you had 2, 8, 8, 5. The x values flipped and became the y values in the second matrix, and they also changed signs. So and the same thing happened with the x coordinate, or sorry, the original y coordinates, 1, 1, 4, 5. They became the x coordinates, and they switched sign. So you get -1, -1, -4, -5. And if you graph it, this is what it looks like. If you, let's say we were using patty paper here, so tracing paper. If we drew this line on our patty paper and on the original paper, and we drew this original shape here on both the original paper and the patty paper, and then we picked up the patty paper and we flipped it over this blue line here, the y equals negative x line, the image that would be on after it's been flipped over would be this green one right here. Then we could copy that onto our paper. So there you have it. That's rotations, reflections, just a lot of extra practice really what we're doing here with multiplying matrices with ones and zeros and negative ones. And that's it. That's all you have to do. So that is that lesson. Go ahead and do the exit ticket and your homework.